Do you ever just start a new project, all big-eyed and motivated, and you get a lot of things done, you sacrifice all your free time, and while you do still plan to get back to all the projects you've shelved for the time being, this new project is too good, it's too captivating, you just can't let it be. And then you hit a snag, and maybe something else in life takes focus, and suddenly it's been 2 years since the last time you even opened the project. Yeah, no, no, me neither. Hello everyone, and welcome to this week's weekly update to the 3D Gravity platform. I am the Snitter, and I'll be your host for the evening. I'll be kicking this week's video off with a recap of everything that's happened to this project since its humble beginnings as a 1-hour programming challenge. Starting with an empty GameMaker project, I spent a single hour, and by using exactly 0 pre-existing assets or scripts, I ended up with a spherical player that could jump around on spherical planets. The second and third videos only added more shapes to collide with, like capsules and blocks and disks, and by the fourth video I was so tired of looking at the terrible sky texture that I made a procedural sky shader with moving clouds. Still wanting to improve the visuals, I went on to making a rim lighting shader, and I also used a trick with blend modes to draw a circular shadow beneath the player that actually follows the shape of the ground. In the 7th video I got a bit sidetracked and made a black hole that also warped light around it for a pretty cool effect. GameMaker famously does not natively support 3D graphics, so getting even a static model to draw is a hassle, and animating them even more so. This is where community-made tools come into play, and in the 8th video I mention several ways to animate 3D models, and I show how I do it with the SMF model tool, which is a tool I made. I felt the dark part of the sky shader was too boring and too monotone, so I added a twinkling starry night sky in the 9th video, and in the last video I published, I greatly improved the controls of the player character by giving it a bunch of new animations, a bunch of new moves, and I connect them all together using a finite state machine. And that brings us to today. Even though there hasn't been any new videos, I've made lots of minor visual changes. The lighting uses a lookup table instead of a linear scale, and the sky shader has seen thousands of tiny tweaks and edits. The player has a black outline, which is done by extruding the vertices along their normals and drawing the model with an inverted cull mode. Oh, and also the grass texture has finally been replaced. But what's missing now is the collision system, which I removed completely when adding the finite state machine. It's time to add it back in. And for that I'm going to use ColMesh, which is another system that I made. This is available for free at the GMC, and in short it lets you move a capsule out of a collision mesh. Importing it is as simple as just dragging it into the project. I don't need the demo or the included files, so I'll exclude those. And I'm left with only the functions from the ColMesh system that I actually need. I'll initialize the ColMesh in the system object. There are several subdivision structures you can choose from, but I'm starting with the simplest of them all, which is just a list of all the objects in the scene. I'll add a single disk to the scene, which is defined by its central position and the normal vector of the plane defining the disk, and the radius of the big circle and the small circle. To actually add the disk to the level model though, I have to use the function called cmadd and give it the level ColMesh and the disk. In the draw event I'll use the cmdebugDraw function to make the level ColMesh draw all the shapes that it contains. They are drawn with a very rudimentary shader. It's just for debugging, but it lets you see where the shapes actually are. Of course, the player isn't colliding with the level yet. For that, we have to go into the player's create event, which is where we define the collide function, which is used by the player's finite state machine. Right now, it's only checking for the Z position of the player, and if that's less than some value, then the player just stops. I can comment all that out and start fresh. In order to make the player collide with the level ColMesh, I need to make a collider for it, and that is done with the cmCollider function. This defines a capsule, and you can see a diagram on screen right now for how all the values affect the final capsule. The player's position is stored in a struct called pos, and the up direction is stored in a struct called updare. The slope angle is the angle at which the player starts sliding down slopes. For important objects such as the player, the precision should always be larger than 2. CM displace pushes the capsule out of the level ColMesh, and in order to read info from the final position of the collider, you have to use these macros in the collider array. So, with the collision function done, we can test the project. Oops, well, at least the collisions work. Now let's try adding more shapes. I figure a sphere in the middle will look pretty good. I don't actually need to store the disk anywhere, so I'll just put that directly into the CM add function. And I'll copy that and edit it to add a sphere as well as the disk. So I put the sphere at 0, 0, 0 with a radius of 200, and then we'll test again. Here you can actually see the slope angle argument in action. The player only starts to slide down the slope when he crosses the 45-degree border. If I go back out and change the slope angle to 10, for example, and try again, you can see that it's much more difficult to find the area where the player can stand still. He just keeps sliding down the slope. Anyway, let's change the slope angle to, let's say, 35. And let's continue trying to make a little level for the player. So for that purpose, I'll remove the shapes from the system create event, and I plan to put them into objects instead. I'll make a new object called OBox, and this will create its own axis-aligned box for the player to collide with. So now I can just place a bunch of these objects into the room, and then we'll test and see what it looks like. Okay, I added a bunch more objects, but I don't like the way they look. I want to use my own shader instead of the very basic included shader. So I'll go in here and replace this. Yeah, that's better. Excellent. Okay, so the player is currently checking for collisions with all the objects in the scene. This is a problem, since the game will run slower and slower the more details I add to the level. And I plan to add a lot of details. So to combat this, we have to limit the number of objects the player has to check. This is done by subdividing the level into smaller chunks. Okay, so if we go into the containers folder, we can see all the options we have. The dynamic is a special kind of container. I'll get back to that later. For now, I'd like to focus on these three. The spatial hash divides the level into a lattice, which is basically a 3D grid, while the quad tree and oct tree recursively subdivide the level into smaller chunks until a condition is met. So I'll start with the spatial hash. Let's go into the create event of the system, and this is where we create the CM list. Now if I comment this out, I can replace it with CM spatial hash. And this takes an argument, which is the region size. The region size is all the dimensions of each cube in the grid, in the lattice. So I'll set that to something larger than the radius of the player. Let's set it to 50, for example. And we'll test and see if it still works. Okay, it still works, but it looks exactly the same. I got a test to see that it's actually doing things more efficiently. For that, I can use the debug draw function on just the objects the player is checking for collisions with. Once we've used CM displace, the list of objects that the capsule has checked for collisions with is stored in the collider array. So I can use this directly in the CM debug draw function, and if I set the color argument to -1, each object will get a unique color, which makes it easier to see each object individually. And with that, I think this is a good place to end the video. Even though it's been 2 years since the previous video, the channel has continued to grow, and it's actually double the size that it was when I published my previous video in November of 2021. I want you to know that I appreciate you all, and I wanted to return to make videos for a while, but I've been so busy. But programming and the game maker community has a big place in my heart, and while other things in life come and go, I know I'll always be able to return to this amazing community. So thank you for watching, please take care, and I'll see you for the next video.